You are currently a heat source. You are a biological furnace running at 98.6 degrees, surrounded by a universe wanting you at negative 460 degrees. In a snowstorm, that universe gets impatient. It stops asking nicely and starts stealing your heat. Through conduction, convection, and radiation, you have exactly 3 hours before your core temperature drops below the threshold of consciousness, and maybe 2 hours before your fingers turn into useless frozen sausages. That can't even hold a match. If you think you can just flick a Bic lighter or rub 2 wet sticks together like a cartoon character, you are already dead. You just haven't stopped moving yet. Today, we aren't just making a fire. We are conducting a high-stakes chemistry experiment in a hostile environment, where the variables are wind, moisture, and your own declining cognition. We are going to defeat the thermodynamics of winter using physics, a knife, and the brutal truth about combustion. Most people die in the cold because they panic. They run around looking for dry wood on the ground. Let's look at the physics of that. Snow is water, the ground is frozen water. Anything lying on the ground is a sponge. If you try to light a wet branch, you aren't starting a fire. You are boiling water. Wood cannot burn until the moisture inside it reaches boiling point and evaporates completely. Until that water is gone, the temperature cannot rise. It cannot reach the ignition point of cellulose, which is around 500 to 600 degrees Fahrenheit. You don't have enough heat in a match to boil wet wood. You need a new strategy. You need to stop looking down and start looking up. The first rule of snow survival is that the ground is lava. Cold, wet lava. It sucks heat away up to 25 times faster than air does. If you build your fire directly on the snow, the heat will melt a pit and the water will rise, and your fire will drown in its own success. You need a platform, a raft. You need to build a floor of thick, wet logs, wood you don't intend to burn immediately, just to separate your combustion reaction from the ice planet underneath. This is thermal decoupling. It's the difference between a fire that roars and one that dies. Now let's talk about your ignition source. If you brought a butane lighter, throw it away. It is useless. Butane is a gas that is stored as a liquid under pressure. To work, it needs to vaporize. The boiling point of butane is 31 degrees Fahrenheit. In a snowstorm, if the ambient temperature is 0, your lighter fluid stays liquid. It won't turn to gas. You can flick that flint wheel until your thumb bleeds, but no gas means no flame unless you keep that lighter in your armpit to warm it up. It is just a piece of plastic trash. Matches. Good luck striking them when your hands are shaking with stage 2 hypothermia and wind blowing 30 miles per hour. You need sparks. You need a ferrocerium rod. A ferro rod creates sparks burning at 6,000 degrees Fahrenheit. That is hot enough to ignore the wind and insult the moisture. It is a mixture of iron and mischmetal. Lanthanum, cerium, and neodymium. When you scrape it, you are shaving off ribbons of metal that spontaneously combust in the presence of oxygen. This is aggressive chemistry. But a spark is not a flame. A spark is a tiny fleeting star. It needs a home. It needs surface area. This brings us to the most critical concept in fire science: surface area to volume ratio. A log has low surface area and high volume. It is impossible to light with a spark. You need to mechanically process the wood to increase surface area. You need to make feather sticks. This is where your knife becomes more important than your jacket. You need to shave thin, curly ribbons of wood, keeping them attached to the stick. These curls are thin enough that the moisture evaporates instantly, and the cellulose reaches ignition temperature in milliseconds. You aren't burning wood, you are burning wood shavings suspended in air. You are creating a structure that traps oxygen. Where do you get dry wood in a blizzard? You find standing deadwood, trees that have died but haven't fallen over. They are off the wet ground. Gravity has drained the sap. The wind has dried the bark, but the outside is still wet from the snow. This is why you need to baton. Batoning is using a heavy stick to hammer your knife through a log. You need to crack the wood open to get to the heartwood. Inside a standing dead tree, the wood is bone dry. It has been waiting there protected by the wet outer bark. You split it, you shave it, you expose the dry fibers. You are mining for calories of heat hidden inside the tree. Let's talk about accelerants. Cheating is not only allowed, it is encouraged. If you have duct tape, you have fire. Duct tape is made of a polyethylene mesh and rubber adhesive. It burns hot and it burns slow. It is essentially solid gasoline. Roll a piece of duct tape into a loose ball. Don't squish it, remember surface area. Hit it with a spark and it will catch. If you have petroleum jelly or lip balm, smear it on a cotton ball or a piece of cloth. Petroleum jelly is a hydrocarbon. It acts as a wick. It extends the life of your flame considerably, from 3 seconds to 3 minutes. In a survival situation, 3 minutes is an eternity. It gives you time to dry out your feather sticks. It gives you a margin of error. The structure of your fire matters. In a snowstorm, the wind is your enemy. It blows away the heat before it can accumulate. To sustain the chain reaction, you need a brace wall A reflector. Build a wall of logs on the windward side to block the gale. Build your fire in a V shape against that windbreak. This creates a microclimate where the heat can build up. You are building an oven, not just a campfire. You need to trap the thermal energy, but the biggest threat isn't the wood or the wind. It is you, it's the umbles, stumbles, mumbles, fumbles, and grumbles. As your core temperature drops, your body pulls blood away from your extremities to keep your heart and brain alive. This is vasoconstriction. Your hands stop working. You lose fine motor skills. You can't zip your zipper. You certainly can't manipulate a lighter or carve a feather stick. This is why you must practice these skills until they are muscle memory. You need to start a fire with hands feeling like wooden blocks. If you wait until you are shivering uncontrollably to gather wood, you are too late. Shivering is your body burning its last reserves of glucose to generate friction heat. It is the final warning bell. Once you have the flame, you must feed it, but don't smother it. A fire breathes. It inhales oxygen and exhales carbon dioxide. If you dump a pile of heavy wet logs on a tiny flame, you will crush it. You will cut off the airflow. You need to feed it small twigs than pencil-sized sticks. You have to earn the right to burn the big logs. You are raising a child. It starts weak and hungry. You have to nurture it. Only when you have a bed of coals can you relax, a glowing, pulsating heart of heat. Those coals are the battery. They store the energy. The flames are just the show. The coals are the workhorse. Let's go deeper into the chemistry of wet wood. When you put a damp log on the fire, you hear hissing. That sound is the water boiling and escaping as steam. Steam is a cooling agent. It expands 1,700 times its volume, pushing oxygen away from the wood. It is actively fighting your fire. This is why you stack wet logs around the fire, not directly on top of it. You dry them out with radiant heat first. You let the fire pre-process your fuel. You create an assembly line of drying wood. You also need to understand the color of smoke. White smoke is mostly steam and unburnt fuel vapor. It means your fire is cold, it is choking. It needs more oxygen or drier fuel. Black smoke is unburnt carbon. It means incomplete combustion, usually because it's oxygen-starved. Blue or clear smoke is perfect combustion. That is the goal. You are converting fuel to heat at maximum efficiency. In a survival situation, efficiency is everything. Every calorie spent gathering wood is a calorie you need to replace. With food you probably don't have, consider the tree species. Not all wood is created equal. Softwoods like pine, spruce, and fir are full of resin. Resin is nature's gasoline. It burns hot and fast. It pops and sparks. It is perfect for starting a fire. Hardwoods like oak, maple, and birch differ. Birch bark is the holy grail of the north. It contains bitumen oil, a natural fungicide that is highly flammable. Even wet birch bark will burn like it was soaked in kerosene. If you see a birch tree, peel the paper bark. It is the gold standard of natural tinder. Hardwoods burn slower and create longer lasting coals. Start with softwood for heat, maintain with hardwood for sleep. Let's talk about the psychological impact of fire. It isn't just warmth, it is television. It is a companion in the pitch black of a snowstorm. The psychological weight of isolation can kill you fast. A fire pushes the darkness back. It gives you a focal point. It triggers a primal response in your lizard brain. This reduces cortisol levels, it clears your head, it allows you to make a plan. Without fire, you are just prey waiting to freeze. With fire, you are an engineer altering your environment. What if you have no knife? What if you have no tools? Then you become a scavenger. You look for the witch's broom, those tangled masses of dead twigs stuck in pine trees. They are dry, brittle, and aerated. You look for old man's beard lichen. It hangs from trees dry and fibrous. It takes a spark instantly. You use brute force to break branches. You use sharp rocks to scrape bark. You use the battery from your headlamp and the foil wrapper from your gum to create a short circuit and a flame. You improvise, but you never ever give up. The fire triangle is heat, fuel, and oxygen. In a snowstorm, the wind provides too much oxygen. It blows the heat away. The snow wets the fuel. The cold steals the heat. You are fighting a war on three fronts. You manipulate the triangle. You shield the oxygen flow. You dry the fuel. You concentrate the heat. Remember this, the cold is patient. It will wait for you to make a mistake. It will wait for you to get lazy, to stop gathering wood, to fall asleep without banking the fire. Do not let it win. Fire is not a magic trick. It is a chemical reaction that you must manufacture, protect, and feed. It is the only thing standing between you and becoming a permanent part of the landscape, so find the standing deadwood. Bait on it to get the dry heart, shave it to increase the surface area, strike your sparks into the tinder, build your platform, protect your flame, and stay alive. Because the moment that fire goes out, the timer on your life starts ticking down again. Science is the only survival kit you can't lose. Use it